Thanks for joining me today. So as you can see, my name is Eddie Bulpitt and I'm a technical relationship consultant in a team called CATS, and that is Consultancy and Technical Services. We are trying to form another team just so we can call it DOGS, but that's something for the future. So our job at Ordnance Survey is really to sort of serve as a second point of contact for customer support. And our main customers are pretty much mainly in the public sector, and these include central and local government, blue light services, education, cabinet office, and the military, to name several of those. But we also do quite a lot of work in the private sector too, and we work closely with utilities insurance. So really the purpose of today's webinar is to talk to you about Ordnance Survey data and what it can do. I've seen the list of the stuff that's available to you under or what you can get through Digimap, and it's quite an extensive list. And given the time restraints, I don't really want to go ploughing through every single one of those. So I'm going to do quite a few of them to give you an introduction. And it's going to be quite a high level introduction as well. And I was talking to Nick about this before we started, and what we thought might be a good idea. If there's anything that actually piques your interest, then we're more than happy to come back and do a more in-depth demo on a particular product or a product group and what else you can do with it. So today, it's really going to be a bit more high level. So what our products and services can be really condensed into are to answer certain questions like, where am I? What is this? Where are you? And how do I get to you? And they broadly fall into these 5 product categories. So we've got topography, we've got addressing, networks, imagery, and height. Okay. So I'm just going to start off with talking about what we refer to as OS in-life products. And these are those products that we're all familiar with. It's topo, addressing, roads, and others. And we call these in-life products to differentiate these from the OS NGD data or National Geographic database data, which I'll touch on later on. Okay, so most of our products that we use are created or derived from the National Topographic Database. And this database contains nearly 500 million individual pieces of information that pretty much describe Great Britain, detailing everything that you can trip over or bump into. And the image or the video that's going on in the background just goes to show you how much change can happen in an environment at this large scale over a period of about 5 or 6 years. And if any of you can recognise that area, that's a part of Swindon. So our Ordnance Survey's primary task is to maintain the currency of this database so that we have the most current view of what is around us as possible. And many of our other products are derived from this layer and generalised to make the smaller scale products like VectorMap Local, VectorMap District. What I mean by generalised, if anyone's unsure what that means we're looking at this very, very large scale data. And going back to my old Carto days, we used to use an acronym, ESSO, which is emphasize, select, simplify, and omit. So you basically, as you zoom out into sort of smaller scale data, there are things that you can take away, and we'll touch on that later when I talk about the products in a bit more detail. So in this image, this slide indicates the products that are available under the PSGA, or the Public Sector Geospatial Agreement, which is an agreement we've got with government. As you can see, there are options on here, not only to download the data. Let me turn on my laser pointer as well. So there are a lot of these images that you can just download. But if you look down the bottom as well, you'll see that some are available through APIs or application programming interfaces. Now, downloading data means you've got an overhead of translating and storing the data in the database. Using an API reduces these overheads, of course, because it saves you the trouble of translating and storing the data, but it'll also show you what is current. Now, this is a bit of a trade-off, if you like, because a lot of the APIs will just show you what is there now. The databases do give you that luxury of being able to create an archive, so you can see what used to be there, which is important for people like blue light services, ambulance services that may want to keep a legal record of what was going on previously. And this slide indicates that some products that aren't available under the PSGA, like imagery, but this slide is also useful because it indicates what is available as open data or freely available to anybody at source. So hopefully, if this works, let's have a look at some of the data. And you'll excuse me as well, but I've got quite a few notes as well. So, close. Right. So let me just move back to where I'm familiar with. So any of you that are fairly eagle-eyed will recognise, I've moved again, we'll be able to recognise that as the Ordnance Survey building. So it's just, right, that's better. So I was talking about APIs earlier on. I do apologise, but this has thrown me a little bit because I've been used to using a larger screen so I can see a bit more. But this is an indication of, in the background, what we're looking at here is an API, or the OS Maps API. So what this means is this is getting dragged from an API server. So I'm just asking to have this data. There are many flavors of the API. So that's the outdoor, that's the road version. So it's basically the same data, but styled in a different way. And if I click on leisure, and that calls up eventually, there we go. That's basically just a 25,000 scale raster that we use for our Explorer maps. And I've also got something else turned on, not going to turn off because I'll touch on that later on. Okay, so for the purpose of this, I'm just using the Light Map API just so that I can move around. Okay, so I'm going to talk about the flagship products to start with. Let's just zoom in a little bit more and get back to where I hope to be. So there we go. That's fairly familiar now. Right. So first of all, I'm going to refer to my notes as well. So I mentioned to Nick as well, I do tend to ramble a bit when I get going. So I'm going to have a bit of a script here just to keep me on track, if you like. Okay. Now, so what we've got here is OS MasterMap Topo, and this is arguably our flagship product, and it is the most detailed mapping that you can get in GB. And the whole of the country is covered at this scale of mapping. And I think I'm right in still right in saying that we're the only country in the world that has got a whole of our nation mapped at this scale. So it's broken down into 6 themes, and I'll just turn a few off just to show you what I mean. There's a boundary line layer, and it's called boundary line because the geometry is basically a line. But it's not the de facto instrument, if you like, for legally outlining the outlines of the local authority boundaries. That is actually one of our open data products, again, called Boundary Line, but is actually a polygon data set. So with the boundary line in OS MasterMap Topo, as it's a line, you are going to get some of the boundaries that are going to sit on top of each other. And if that's the case, the boundary hierarchy comes in effect, and you will only show the boundary that's at the highest level of that hierarchy. And the hierarchy is basically county, district, CP or civil parish boundaries, ED or electoral district, and ward. So it's a good indication, but it can't be used for legally proving the outline of an LA. That comes from boundary line. Next, we have got the cartographic symbols, and as the name suggests, they're just they're just symbols that you see on the map. And again, we've got the cartographic text. Now you'll notice that with the cartographic text and the cartographic symbols, there's an orientation in the attribution. Okay, and what I should have said was a lot of these vector data, they all contain similar attributes like toid, descriptive group, descriptive term, and feature code, for example. They're common across all of the layers, but some of these will have extra attribution like orientation. Topographic line, let's just turn off the API for a minute. So there you go, there's the topographic line. There are some important attributions in this. So let me just scroll up to it. Where is it? I've lost it. There we go. Leave that for a minute so I can get the information button. There's some important information in this, in the physical presence. For example, this line, an edge or a limit, and that just describes different surfaces. It might be sort of moving from a man-made surface to a natural surface, for example. And if you compare that to the edge of the building, that says the physical presence, that is obstructing. So you can actually bump into that. If it's an edge or a limit, pretty much all of the time you can walk over it. Okay, so that's an important factor in the topographic line. Topographic points, excuse me. Let's just turn the light layer back on. As the name suggests, these are just point features. It's just one set of coordinates. Lines have got multiple coordinates from start to finish. So we use points to identify things like, in this instance, the flagstaff out the front of the OSHQ, or telephone call boxes, or if I move this up a bit, we've got some bollards or some posts there. We usually only show bollards where they obstruct traffic. Right, so if I then turn on topographic area, there's some important attribution in this as well. So I'll click on the information again on topographic area. One of the most important attributes in this is the calculated area value. And also, if you look at the TOID, that is the topo area TOID. And you may have come across the building heights attribute, which is a CSV file that is available. And this will adjoin on the topo area TOID and apply heighting information to that. So what you can do then is you can use this to extrude, buildings to create a 3D version of what is around you. And I've got a slide that will show that later on. Okay, so this is pretty much, I'll turn all the layers of topo back on again then. This pretty much describes everything in the real world you can trip over or bump into. And as you can see there, it says this is Explorer House, and it's the Ordnance Survey head office. Excuse me. So that describes or explains what the yes, please. This explains what the actual building is, but it doesn't describe it down to the finer details. So what we've also got is where's my addressing layer gone? Excuse me. So we've got addressing products, and let's just turn off topo. So hopefully that you'll be able to see that now. Yeah, so we've got addressing products, and what this basically does is describe the built environment. We've got several address-based products. We've got AddressBase, which is our entry-level address-based product, which is pretty much a geo-referenced postal address data set. We've got AddressBase Plus, which you can see here in the points on the map, and these are postal addresses, but also geographic addresses, which I'll explain in a minute. We've got AddressBase Premium, which is pretty much the same as AddressBase Plus, but it's got more history, and you really need to load that into a database. Excuse me. And we've also got AddressBase Core, which is released weekly, whereas these other address products are released 6 weekly, like Topo. And the differences are, with AddressBase Core, you've got a full address in it. With AddressBase Plus, AddressBase Premium, you'd have to create a single line address. But with AddressBase and AddressBase Core, you get a very, very basic classification. What it will tell you is that there's the building you're looking at is residential or commercial. What you actually see with AddressBase Plus, if I click on information, is quite a lot. You can see there's a lot of attribution there. And this is the important information. There's a classification, RDO6. And I'll click on another one. That should be RDO3. So this basically tells you that it's a residential address. If I click on the Ordnance Survey, for example, the classification changes to C0, which I don't pretend to know all the classifications, but this is commercial, this is an office, and the GV means it's government. Day nursery is commercial, the E means it's educational. Thanks, Nick. But there's also some more important attribution that's contained in address. We've got the UPRN, or the Unique Property Reference Number, and this is now becoming the industry standard by which all businesses recognize an address. So we click on the Ordnance Survey again, the UPRN there that you can see that bunch of numbers there. Everybody in any industry, be it insurance, government, local authority, if they click on that UPRN, they know that will be the UPRN for Ordnance Survey. There's also other important information in there, if I can find it. The USRN, which is unique street reference number. So this is the street reference number that is located or located with that particular building. So we've also got here the addresstoid, the road linktoid as opposed to the street, because obviously in highways you've got a road link, you also got a street, but I can explain that later as well. But you've also got the topotoid. So that is the topo areatoid that we mentioned earlier that you can attach the building heights attribute to. So, and it also useful for open identifiers, because if you've got that that addresstoid, you also know what road link it's associated with, and you also know what a topotoid it is linked to. So hopefully you can now start to see where everything starts to join together, everything's linked together. So now with address, the classifications, and with topo, we've now identified things that you can trip over and bump into in the real world. But we've also been able to go into a lot more granular detail. We've been able to identify those, and we've been able to give them a classification and a lot more other information. But there's something else that we want to do as well. Let's just turn that off for a moment, and we'll go to OS MasterMap Highways, and hopefully turn those on. This is the road network, and this again is line geometry. So again, it's got, let's just click on the road link and click on one of these. This attribution, the thing, the joy with vector data is, of course, it's got intelligence. So we know the road classification here is motorway. In this particular instance, it's a slip road, so it's this coming off the main road, a connecting road to join the motorway. But importantly, it's got a length as well. So this particular, let's move so you can actually see it. So this particular road link has actually got data, a length attached to it. So that we can use this to start creating a network. If you select a point, say over here, and another point further away, or if you've got a sat nav, you can put your postcode address in. It will join up using those links, and it will know exactly how long that data set, although those links are, so it can calculate a journey distance. If you've associated average speed limits or speed limits to that data, it will give you that journey time as well. So this is pretty much the basis of how you start to navigate between points in the map. So that's highways, but we've also got, and I noticed in your Digimap products, you've also got paths. So this is another useful addition to the data. If I turn those off again, turn them off and turn them on so you can see where they are. So those are the paths. And this is a link using data from the descriptive groups and descriptive terms, where this is classed as a path or roadside. There's other things we've got in the past data. If you just look here, there is an inferred link between the end of the path and the road. This is so that we can create a network between the paths and the roads. This is making the inference that once you get on the road, there's going to be a pavement that you can follow. So you're not going to ask people to walk down the road. In other places, you might see, for example, if I'm trying to try and find one, for example, here, if you can see my hand moving there, there's a path there, there's the inferred link connected to the road. But using the topo lines feature, this is up against an obstructing line, so it can't travel through there. Whereas here, if I zoom in a bit, that property is going to be an edge or a limit, so the line can go through there and join up to the road network. Okay, so this is how we can start creating networks for the paths and the roads. Now, the path network is very, very useful for local education authorities where they want to start looking at catchment areas. And this is more useful to use because you can actually route between an address to the school it's going to, which is a lot fairer than just doing a point-to-point as the crow flies kind of data or kind of calculation. And also, what's also useful for the local authorities is, if I can find an area of woodland, there we go. We've got paths here. Let's just turn off the. So these are paths going through woodlands, as you can see there. Now, those would be regarded as perhaps unsafe routes to school. So the local authority has got it in their gift, if you like, to either delete those, remove those from the path network, or just to put a flag to those to say these aren't safe route to school, therefore they're out of bounds. So with this, hopefully you've seen, like I say, this is a very, very high level view of roads. But now we've seen what we can trip over, bump into. We've given everything in the built environment a name, and we've also looked at how we can get between them. So now I'm just going to have a quick look at my notes as well, because PARS, and I've talked about buildings height attribute. Now, some of the other things you're interested in is OS MasterMap sites layer. So if I just zoom out a little bit, turn that on. Now, sites, as the name suggests, these are large areas. And if I expand the functional site, you can see that we've got a bit of a, excuse me, I'm just going to have a sip of water. Thanks for getting that, Nick. Thank you. That's better. Right. So sites, you can see it's split up between air transport, education, medical care. Okay. Now, what you do find in the built environment, that's the Southampton General Hospital. I'm just going to make a quick change here. So hopefully, there we go. Style rendering. Just going to make them a bit more see-through. So I'll give that 50%. Okay. There you go. So hopefully you can see that. So this is the OS MasterMap sites layer, and you can see underneath this is Southampton General Hospital. Lots and lots and lots of buildings there. So talking to customers, they said, we know where the Southampton General Hospital is. We don't know how to get into it. We don't know how to access it. So what we've got here, we've got access points, motor vehicles and pedestrians, which are the blue ones, or pedestrian access. And this makes it easy for people that might have to deliver to the site. They know where those entrance and exit sites are. So that's the hospital. Education sites, the same thing. Some education sites are going to be quite big, like Southampton University, for example, is a large site. So you're going to need to know how to get in and out of that particular site. Okay, so that is a very, very useful piece of information, very useful data set. So I'm just conscious of time now. So I'm going to show you some other things like open green space, for example. This is open data that's freely available to anybody that wants to use it. And this basically shows what green spaces there are within an urban environment. And these data sets were created in response to the government initiatives to make sure everybody has access to amenities they can easily get to within an urban environment. Now, if I go up here, we've got a green space area in Topo. And I can't understand what's not drawing up at the moment. Let's just turn that one off. Unfortunately, it's not drawing up at the moment. I don't know why. Is it because I'm not zoomed? I'm too zoomed in. Oh, there we go. I was zoomed out too far. So the main difference is between the paid for one is there obviously is a lot more information in it. We've got residential back gardens, which you don't have in the free one. But of course, the main thing is, of course, is they've got golf courses, which is always useful. But what this is useful for, whether you're using it as open data or as the paid for data, it's a very, very good indication of what data or what the land use is in the background. And it's useful, again, talking about creating archives. You can look for changes over time to see how that is, well, that use of the ground has been changed over time. Right. Right. Now I'm going to jump onto your Digimap list to see if there's something I haven't covered. Water network. This is another one. Now we've got two offerings here. We've got the OS MasterMap water network, which if there's a bit of water over here, I'm pretty sure. Turn that on. So here we go. So this is the water network. We don't have many customers for this, but the Environment Agency find this very, very useful because it allows them, one of the things they do use it for is if you look at the data, just click on that. Let's get my information button. Oh, everything stopped working, which is typical. Right, information. Click on that. There we go. So there's all sorts of information in this, whether it's a tidal river, it's on surface, it's got a watercourse name, it's got a width, which is important, and it's also got a gradient. Now, you would expect that to be 0 all the time, wouldn't you? Because water will naturally take on will be flat, it will settle to a level. But what the gradient actually is if the start of this node here was higher than this one, that would be the difference in the height. So you could effectively say that water is going to run down from the highest point to the lowest point. And if you've got a gradient, you can use that to indicate what the force of that flow is going to be. So this is the paid for version. The open version, if I can find it, Open Rivers. It's still a very good data set, but as you'll see, you don't get quite as much information. So it gives you the indirection, which is useful, and it gives you the link length, which you've got in the paid for version, but what you don't get is the river width or gradient or anything like that. So it's still a useful data set nonetheless, but doesn't give you half as much information as the paid for version. Backdrop mapping we can touch on now because we've got rasters in here. We don't need the grids. So I'll zoom out. Let's say stop and turn that off, get rid of that. So zoom right out so we can look at the backdrop. Actually, no, I'm going to start with the 25K because we were talking about generalization earlier on, weren't we? So what we can see here with the 25,000 mapping, it's you can see where we talk about generalizing, it's simplifying. So all these buildings have been grouped together and we've omitted, if you remember the acronym ESO, we've emphasized some of the building names, names here, for example, Business Park is standing out. We've simplified some of the details, so we've taken out some of the back garden fences. We've selected things that we want to show more of, like, for example, a telephone call box. That is important for navigation. And we're omitting things. So we're omitting quite a lot of back garden fences, a lot of other larger scale detail. So as we go through the scales of mapping, for example, we can now go to 50,000. Again, this is still used for navigation because we've colored up the roads as we did do with the 25K. You can see this is the edge of the New Forest. So we've got national park boundaries. But you can see the buildings are now blocked in. You can't really identify any single buildings. So you just know that that area is built up. We've now started introducing symbols as well, or more symbols, I should say. We've got pubs, we've got nature reserves. What else have we got around? Urban wildlife centres. Typically, I can't find any other symbology. Oh, there's another wildlife sanctuary there. Okay, so but as you can see, if we zoom out more, you can see this is getting more and more towards navigation purposes. Still got useful information in, like woods, paths are still in there, but not all of them. Again, some of those would have been selected and omitted. So if we can go to 250,000. From this, you can see there's very, very little detail. You know that that's a built-up area because it's been coloured in grey. You can make that inference. City names are exaggerated. And again, you can see all the road names and motorway names are exaggerated as well. So you can really start to see this scale of mapping is all about navigation. And if you go to mini scale, that is even more true because there's even less information there as well. But it's all about the navigation. So this comes down to what you want to use your backdrop mapping for. And this is probably best regarded as a national data set. And then we start getting down to regional and, well, again, 250K is probably arguably that's going to be regional as well. So it all comes down to depending what you want to use your backdrop mapping for, whether you want a global view or, I shouldn't say global view, a national view. And again, you've got to remember that these are more, as you zoom out, are more for sort of navigation purposes. Now, what you might have noticed with the raster is the specification changes. And we found this a bit of difficulty when we've been working only as far back as, say, 2012, when we were working with the Olympics. We didn't have that fluid zooming or transition between the different scales. And this is what prompted the idea for Open Zoom Stack. which is a wonderful bit of kit. And as I say that, it's not drawn up as I would like it to. But what a zoom stack allows, when it does work properly, is it allows you to zoom between almost building level clarity right out to, no, this isn't working properly, so I do apologize, but it allows you to zoom out as well to a national view seamlessly. And like I say, this was as a result of us working on the Olympics about 12 years ago. And we realized that we don't have that scalability between our backdrop mapping. And ZoomStack filled that gap, and it quite rightly got lots of plaudits and awards. And unfortunately, the colleague that I work with who actually designed it has now left the Ordnance Survey. He's gone to work somewhere else. But that leads me on to vector maps. So I'm going to have to zoom in a bit for this one. Vector Map Local, which is, if you like, our new 10,000 product offering. And unfortunately, it's not freely available. It's not open data, but it is a wonderful piece of mapping. And it is really a replacement for our 1 to 10,000 product, because it is captured. The generalization is, if you like, at a 1 to 10,000 scale. And this isn't drawn up properly either. I do apologize. I'm going to have to go back and have a look at this. But if we now have a look at Vector Map District, which is an open data product, you can see you get quite a lot of bang for your buck here, because it really is quite a nice map. Even if it is like a open data, you see you've got a good navigational set of roads there. It tells you where the woodland is. It's a good representation of the water network as well. And this is also, I'm going to try and find open map local. Again, this is a great bit of mapping, considering it's freely available point of use. So again, you've got area names, you've got road names. So for free mapping, this is really quite a useful piece of mapping. Sorry, I'm referring back to what you want to see in Digimap. Okay, land and height data. Now, unfortunately, I don't have a DTM loaded up here. But what I do have is Terrain 5, which is let's chuck on the light again in the background, which is just obviously, as you can see, the contours. And we've got Terrain 50, which is the open data version. The difference being is obviously the accuracy of the data. And with Terrain 50, you get the master contour as well as the ordinary contour, the spot heights as well. But it's really the accuracy, and this applies to the DTM as well. It's the accuracy of the height data you're looking at. Now, with regards to the DTM, we create those from what's got an ASCII file, which is, if you like, if you imagine a raster image, each of the pixels has a color value associated with it. All of the pixels in an ASCII grid have got a height value associated with it. So this is what allows you to view or create a DTM and view hill grading, for example. And I'm going to talk about DTMs as well in a use case in a minute. Okay, right, stay here. So paper maps, always important to have a paper map, because like I say, it could be the center point of like I say, a command and control center. Everybody can interact with it. And of course, one of the important things as well, if you ever go walking out in the countryside, doesn't have a battery, you can use it anywhere and anywhen. So, and also it forms a focal point, again, using a control and command and control center example. Everybody can stand around it, everybody can point at it, everybody can interact with it. So this one here is quite a small scale one. But this is a large scale map of Southampton Airport. And historically, we've had to provide this kind of mapping under something we do at Ordnance Survey called mapping for emergencies, where unfortunately there might be an accident at the airport, and this is used for sort of forensic fingertip searching. So with all this masses of data that we have got, there is always going to be a place for paper mapping. Now, let's move on to it. Hopefully we can now see more of a blue screen. Yeah, cool. Right, now sometimes and this is an insurance. This was a job we did for an insurance company. Sometimes they don't really want to know about the mapping. They just want to know about the sort of data that's associated with it. Now, remember I was talking about the industry or the UPRN that is rapidly becoming the industry standard. We can associate all sorts of other information with a UPRN. And remember, we were talking about the topo areas as the calculated area value. We can take out some of those values to sort of like the total plot area, the total building area. And then over here, we've calculated how to identify detached, semi-detached, terraced, end-of-terraced houses. We can give that information there. And all this information has been arrived at empirically. So it's basically set out in a technical specification, for example. So we can explain how this data was arrived at. We've got high rise here. Now, again, this is based on information that we've got from the building heights attribute that has been attached. Remember, we were talking about the OS topographic toid. That is an attribute in the building heights attribute. So is this high rise? We had to do some work with the government as well after the tragedy at Grenfell, where we wanted to identify high rise buildings. So we were trying to identify any building that was over 15 meters high, and we could do that using the building heights attribute attached to the topographic area toid. So we've got all sorts of other things here. We've got distance to the road, distance to the water, but we've also introduced other elements here from ONS, or the Office for National Statistics. So we can introduce some indices of multiple deprivation like crime, employment, what else have we got there? Crime counts, burglary, flood risk. We can incorporate flood risk polygons from the Environment Agency. So you can put all this together. The insurance company can then calculate a risk based on that property or that UPRN or the property associated with that UPRN based on empirically sourced data from not just Ordnance Survey, but from other government agencies as well, all based on the UPRN. So sometimes, like I say, they don't need an image. Now, we were talking about digital terrain models, and we used a technique called viewshed analysis here. We were approached by Border Force, who asked us, can we identify areas of coastland that can't be easily seen from points on the land? So we came up with a methodology for this, where we'd split the coastline into 100 meter chunks, and we put a point in the middle of this coastline, and we'd take that to the nearest point on land that could possibly see that. So if you did this, if you imagine if we were doing this in a completely two-dimensional plane, each of these points would be looking at the coastline, and you'd be able to go, yeah, you can go anywhere in the Isle of Skye, and it doesn't matter where you stand, you'd be able to see the coastline. But of course, anyone that's been to Scotland knows it's not exactly flat. So putting in a digital terrain model, you can start, if you can imagine, use your imagination, there might be some hills in the way of this. So some of these views, you might be standing on that viewpoint, look towards the coastline, you can't see it. Or you might be able to see some of that 100-meter stretch. And using this kind of methodology, we could colour up the coastline around the Isle of Skye, whereas green, you can easily see it, going through scales of yellow to amber to red being areas that you can't see. Now, this was a methodology that we thought up. We ran processes in a database to work out the areas of the coastline that you could see, but we couldn't ground shore it because we're in Southampton at Ordnance Survey. So we gave the information that we found to Border Force. They said, do you want to go and ground check it up in the Isles of Skye? They did, and they came back and they said, that's absolutely bang on. Can you do it for the rest of England? Well, we could, but of course that's going to take a bit of money, because obviously the processing is going to take quite a lot of it's going to be quite memory intensive and equipment hungry. But this is just something you can do in a database using a DTM, the coastline model, and like I say, using a technique called viewshed analysis. And next, this is an example in a two-dimensional plane of the building heights attribute that has been attached to buildings. So this one is sorted out on height. You can see down there on the legend, fairly low buildings going up to 150 meters, which we don't have here, but we do have one, I think, up there that's about 100 meters. This is a useful data set for a number of reasons. It helps town planners look at the impact of a potential new build on the environment. If you put this, there's no reason why you can't put this over on a digital terrain model. So you've got a three-dimensional aspect to it. This is ideal for if you want to sort of like plant radio masts for radio propagation. it's really important if you're looking at building around airports. You need to know the high buildings around an airport because obviously, well, obviously we wouldn't get planning permission if you wanted to build too close to an airport. So those are some of the use cases. Like I say, I could spend a whole day or more talking about use cases for some of our product. We've got dozens and dozens of them, but I thought I'd choose these because it's sort of like three-dimensional, a bit of addressing in there as well. And what was the first one? Oh, yeah, of course, paper maps. Right, to finish off, I'm just going to give you an introduction, a brief introduction to the OSNGD or National Geographic Database. And I understand talking to Nick earlier on that you will have access to NGD and select and build through Digimap, Nick? Yeah. Yeah, okay. So I think this is for the future. So what is the National Geographic Database? So it's available through the OS Data Hub, and the data structure has been improved for the NGD to make the data more useful for analytic purposes, because our existing in-life products, I think it's fair to say, they're still largely cartographic in their specifications. And you could then argue, so why didn't we make the existing data more analytical rather than introduce a new product offering? A couple of reasons for that. One, if we make a change to the specification of any of our in-life products, we have to give our customers at least 6 months notice so they can alter their loaders or talk to their suppliers about altering the way the data gets loaded. But it largely comes down to that costs, those overheads and that customer impact. For example, if you decided to take an old car to a garage and say, you fit, I don't know, air conditioning in this car, garage would turn around and say, yeah, we can do that from scratch. It's going to cost $7,500. You quite legitimately turn around and say, look, buy a new car for that. So, well, yeah, you could. And this is another reason why it was, in terms of cost, it was cheaper for us to create a new product offering. And of course, in terms of cost, it was cheaper for our customers as well. So they could continue to use the existing in-life products, or they could make the decision to transition and migrate away from Topo. But that's not to say the two don't work hand in hand. So, for example, now you can just go into like a Lego shop. You've got the wall at the back. You don't have to select the whole of OS MasterMap Topo, for example. You can just select the buildings. And as we've seen, you can just select the buildings over a certain height as part of that product offering. So the NGD consists of 9 themes, and I'm going to have to read these. I can't remember these, so I'm going to read these. Land use, administrative and statistical units, which is effectively boundaries. You've got water, land, buildings, address, structures, geographic names and transports. And themes are the highest level of the NGD offering. The themes are further subdivided into 13 collections. And what collections do, they group together similar types of data within the theme. So I'll give you an example. NGD water theme. There are 2 collections in water. One is NGD water features, which is effectively the topographic data, and the OS NGD water network, which, as the name suggests, is the network data. So the collections are separating the network from the topographic features in these cases. And the feature type is the most granular level of grouping within the themes and collections. And feature types have their own data model and their own specification. And these aren't commonly shared with other feature types, so there shouldn't be any confusion between the different feature types. And when you order data through OS Data Hub and the select and build, or whatever the Digimap offering is going to be in the future, the data that will be delivered will be someone else's teeth in at the moment. That data will be provided at the feature type level. So, going to have a quick look at one of the data sets that you can access with the NGD through the OS Data Hub. Again, we could spend hours talking about the different product offerings. Oh, I've gone too far. Let's go back. So let's have a look at land use, as this aligns fairly closely with OS MasterMap sites. So what's the difference between OS MasterMap sites and NG land use data? Well, from first glimpse, there's not really much difference. You've got a site, you've got a polygon feature, and you've got access points as well, which we've already talked about in OS MasterMap sites. But the difference being here is we've got a site routing point as well. And this actually sits on the road routing network. So instead of just finding an OS MasterMap site, you can actually navigate to this point in using a routable software. But the biggest difference is in the attribution. This new attribution makes land use sites much more user-friendly. There's still going to be a TOID associated with it if there is one that's readily available in the in-life data. But all of the NGD data now has a unique identifier called an OSID, but this is unique and it is persistent. This will stay with that, whatever this particular attribute or whatever this particular feature is. It will stay with it from when it first came into existence through all its modifications, and when it gets deleted, it will still be there as an archive. It won't ever get used again. But what makes this data more appealing is the depth of detail that is available. For example, if we look at this example, we've got OS land use tier A, and this says it's a sports attraction or facility. Doesn't really give you much to go on, but we've also got the OS land use tier B, which tells you it's golf. You may be getting a vibe here that I'm quite a keen golfer. You've also got a description here that describes this as a golf driving range. So you can see this is starting to get a lot more granular. So let's have a look at a product comparison between OS MasterMap sites and NG land use. So as you can see, there is a lot more going on in the NG land use data, but this is land use data as opposed to a sites layer. So this has got a much further reach to people that want to use it. And this can ideally be used for identifying change in the land use over time. OS MasterMap sites layer, or the features within the OS MasterMap layer, sites layer, is still included in the OSGD land use. But of course, the NGD land use forms a much larger data set. So a large proportion of the polygons given over in the NGD land use are given over to residential accommodation. But again, however, this is really useful information in for land use over time. So product comparison 2 here. You can see that there's the offering is a lot more granular. But of course, so you can narrow down your requirements to specific sectors using the land use tier A or land use tier B. But if you want to get really granular, then you can, of course, just select out golf courses if you want. But as you can see there, I don't know if you can, how well you can see that, but just looking at the descriptions there and then compare it to the function, it was the equivalent in OS MasterMap sites, the functions theme, which you could pretty much use OS land use tier B. You can see there is a lot more that you can pick out of the NGD land use data. So what formats does it come in? Pretty much 2, really. It's just CSV and GeoPackage. No GML, because as we've mentioned before, GML requires translation and loading into a database. And got to be honest, that's overhead. Nobody likes doing it. I work with this stuff all day and I don't like doing it. So GeoPackage is rapidly becoming a format of choice because it's self-contained. It's a portable data set. And it's effectively plug and play. You can just drop it into a lot of GIS systems like QGIS, and it will just open. It's I think it's a SQL-like database, so it will just expand where you drop it. And CSV, again, that's universally accepted as a de facto data format that allows rapid ingestion into a database without the need for translation. And indeed, you get some GIS software packages. You can open up a CSV. You can click on the database function and you can just drop it into a PostGIS or an Oracle database quite simply. So how do you order it? So from an OS data hub point of view, you have to be an account holder that allows you to access premium data. Otherwise, you can't get hold of this. But once you sign into OS data, you can select the OS select and build. And I'll just jump on to the next slide because it makes it look a little bit clearer. So you can create your recipe. So you give your recipe a name. So if you want to go back to it, you can find it in future. You can share it with other people within reason. But the important thing is this is where you can start filtering the data. So here you can see this. This is still, we're filtering on land use tier A, and here we've got community services other. But down here you can see we've got sports attraction or facility, residential accommodation. So this is all the flavors of OS land use tier B. You can further cut that down to OS land use tier B, or indeed, as we've discussed, description. So this gives you that option to get a lot more granular data without having to download a whole data set like OS MasterMap Topo. Don't get me wrong, I'm not going to knock MasterMap Topo because it's a very, very important very important data set, but more options for our customers to choose from. So I'm sorry, I think I might have overrun more than little. I did warn you, I do tend to ramble. So that's it. So any questions? Happy to answer them now, or we can take them away. I think Emma, Denise have got our email addresses. So please feel free to drop us an email if you've got any other questions. And like I said at the start, this has been a very, very high level, a quick blast through. So I'm more than happy to talk to Emma or Denise, and we can do a more in-depth demos on a particular product or a particular layer or a particular way of doing things with our data. So there we go.